Hi everyone. Here we are going to discuss about bilinear transformation. Some standard notation of complex numbers or C is the set of all complex number, script T, C. C suffix infinity can be written as C union of all infinite values. We may use the notation in the complex variable as z equal to x plus iy. Here x is a real part and y is a imaginary part. Both are independent variables. Another complex variable is w is equal to u plus iv. Here u is a real, v is a imaginary part. So both u and v are independent. Here z plane is like coordinate axis x and y. Here x is an real axis, y is an imaginary axis. So another plane, in w plane, v is a real axis and v is an imaginary axis. So this is x and y planes we are using in this particular topic. So let us move on to the bilinear transformation or Mobius transformation. Mobius transformation or bilinear transformation. So consider w is equal to s of z, which is equal to az plus b by cz plus d, where ad minus bc definitely not equal to 0. Coefficients are not equal to 0. Where z and w are defined like x plus iy and u plus iv, for all the coefficients a, b, c, d or all belongs to the complex variable c. And c and d definitely not both cannot be 0, because while we are getting c and d 0 means we will get something by 0, that is infinity, that is not possible in mathematics. So therefore either c0 or d0 is allowed, but both are 0 is not allowed. The above transformation is defined as bilinear transformation or Mobius transformation. So next is some important note. In the given above transformation, AD minus BC not equal to 0. That is a necessary condition for Mobius transformation. And S inverse of Z is equal to dz minus b by minus Ez plus a is also a Mobius transformation. S of Z is a bilinear Mobius transformation, and then parallelly inverse also Mobius transformation, because S is bijective mapping, both injective and surjective satisfying. And third one, f of s of z is s of z, ad minus bc is known as the determinant of the Mobius transformation. If ad minus bc equal to 1 means, then s of z is said to be normalized. Last point is, every bilinear transformation maps straight line or circle onto straight line or circle, or straight lines are mapped into straight lines, or straight lines mapped into circles, as well as circle also. Circle mapped into circle or mapped into straight lines, which means straight line, circle mapped into the same straight line, circle, or opposite. So this only we are going to see in under the bilinear transformation. Before we move on bilinear transformation, we must want to know what is fixed point. Now we are going to discuss about what is meant by fixed point. The point that coincident with the transformation are called as fixed points. To find a fixed point, the given transformation as in the form w is equal to az plus b by cz plus d, definitely ad minus bc value not equal to 0. So for finding the fixed point, we need to plot w is equal to z in that given transformation. For solve z, suppose we may get only one fixed point for this equation after solving means, that is called an parabolic type. We may have more than one fixed points. For while you are finding the fixed point, you will get only one point means, that is called an parabolic. Look at the problems. Find the fixed point of the bilinear transformation w is equal to 3iz plus 1 by z plus I. Now, for finding the fixed point, for this given transformation, we need to replace W is equal to Z. So after replacing it, we will get Z is equal to 3iz plus 1 by Z plus I. So next, we multiply Z plus I into LHS side. We will get Z into Z plus I is equal to 3iz plus 1. So next, we are going to solve this quadratic equation. We are getting the value for Z is equal to I. At finally, we will get Z is equal to I. So therefore, we are getting only one fixed point for the given transformation. So therefore, the transformation is called parabolic type. So we are having more than one fixed point means that is not an parabolic. So we are getting for this particular transformation only one fixed point Z equal to I. That's why we call it this as parabolic type. Similarly, we may have the another problem. W is equal to Z by 2 minus Z. Now, for finding the fixed point, we need to replace in the given transformation, in place of W is equal to Z. After replacing it, I will get Z equal to Z by 2 minus Z. So next, of simplifying the quadratic equation, we will get the roots or Z equal to 0 and Z equal to 1. We are getting more than one fixed points that are called Z equal to 0 and Z equal to 1. This is not parabolic type. So the given transformation fixed points are Z equal to 0 and Z equal to 1. So you itself practice these two problems. W is equal to minus 2 plus I into Z by 1 plus I, and W is equal to Z minus 1 by Z plus 1. Now we are discussing some basic properties of complex variables and some useful results. Z equal to x plus iy, that is which is nothing but r into e power I theta in polar form, where r is equal to square root of x square plus y square and theta is equal to argument of z. Also e power I theta we know very well, cos theta plus I sin theta. In complex plane, modulus of z square is equal to z into z bar. So while we are multiplying z and z bar, we will get x square plus y square, because z equal to x plus iy, z bar is x minus iy. It will give x square plus y square, that is nothing but r square, because x is equal to r cos theta and y is equal to sin theta. Next result is modulus of z1 by z2 is equal to, we can split this as mod z1 by mod z2. Next, z1 plus z2 the whole bar is also we can split in by using the linearity property, like z1 bar plus z2 bar. Let us move on to the next category. Real part of z is equal to z plus z bar by 2. While we are solving z plus z bar by 2, we will get real part of z. Imaginary part of z equal to z minus z bar by 2i. So these are all the some formulas. And argument of z1 by z2 is equal to argument of z1 minus argument of z2. Multiplication of argument values is equal to addition, and division of argument values equal to subtraction. Next thing is hyperbolic type. Sin hz equal to e power z minus z by 2, as plus cos hz equal to z plus e power minus z by 2. Like away cos theta formula, e power I theta plus e power minus I theta by 2, and sin theta is equal to e power I theta minus e power minus I theta by 2i. These are all the some basic properties of complex variables. The next formula is cos h I z, which is equal to cos z, and sin h I z is equal to I times of sin z. Also we have two planes, z plane where z is equal to x plus iy, and w plane where w is equal to u plus iv. Also a circle with center h comma k and radius r in Cartesian coordinate system has equation x minus h the whole square plus y minus k the whole square is equal to r square. Here h and k are centers and r is a radius of the circle. And it is represented in z plane as modulus of z minus h plus ik, which is equal to r. Now we are going to see the type 1 category of problems under bilinear transformation. Show that the bilinear transformation w is equal to 2z plus 3 by z minus 4 transforms x square plus y square is equal to 4x in the z plane 2. 4u plus 3 is equal to 0 in the w plane. They are given the transformation w is equal to 2z plus 3 by z minus 4, as well as they are asking to show that the circle is transformed into the line in the w plane. Circle in the z plane is transformed into the line in the w plane. So this I want to show. Consider x square plus y square is equal to 4x is the circle in the z plane. So now we want to make it this as a circle equation like x minus a the whole square plus y minus b the whole square is equal to r square form. So for that I'm rearranging this equation into easy form x square minus 4x plus y square is equal to 0. For making of that, I'm just adding and subtracting 4. And subtraction 4 goes to the right hand side. Now I'm going to make it the perfect squares. X minus 2 the whole square plus y minus 0 the whole square is equal to 2 square. This looks like x minus h the whole square plus y minus k the whole square is equal to r square. Here h is equal to 2 and k is equal to 0, r is equal to 2. Thus the center of the circle is 2, 0 and radius is 2. In the z plane, the circle equation is modulus of z minus h plus ik. H is equal to 2 plus I into k value 0. So therefore, we will get the circle equation is in the form of z minus 2 is equal to 2. Consider that given transformation w is equal to 2z plus 3 by z minus 4. So now, we shall multiply the denominator into LHS side. We will get w into z minus 4 is equal to z plus 3. After multiplying and simplify, we will get, you just rearrange the z term one side and other terms into another side. What are the terms containing z? W z and 2z. Keep that into left. So next I am taking z common in the left hand side. We will get w minus 2. So next I am finding z value. We will get 4w plus 3 by w minus 2. So this is our z value. After simplifying the given transformation, we will get like this. So after expressing z in terms of w, we must want to subtract 2 on both sides because we are having the circle equation z minus 2 is equal to 2. So after subtracting, I will get z minus 2 is equal to 4w plus 3 by w minus 2 minus 2. So now I'm taking modulus on both sides. I will get modulus of z minus 2 is equal to modulus of something. So we may have modulus of z minus 2 is equal to 2. Substitute that value in this particular equation. We will get 2 is equal to modulus of, after taking LCM in the right hand side, I will get 4w plus 3 minus 2 times of w minus 2 by w minus 2. The simplification gives 2 is equal to modulus of, the simplification gives 2 is equal to modulus of 2w plus 7 by w minus 2. I'm splitting the modulus numerator and denominator separately. We can able to do like that. Next, we are cross multiplying the denominator into LHS side. We will get 2 times of modulus of w minus 2 is equal to something. Is equal to modulus of 2w plus 7. The next thing, for removing this modulus, we need to take square on both sides. After squaring on both sides, we will get 4 times of modulus of w minus 2 the whole square is equal to 2w plus 7 the whole square. So now, we know that one complex formula, modulus of z square is equal to z into z bar, some important property of complex variable. So by using that, in the left hand side I am having modulus of z minus 2 the whole square in place of z. So that we can able to express as w minus 2 into w minus 2 the whole bar. Like a way in the RHS side also, modulus of w plus 7 the whole square will be written as 2w plus 7 into 2w plus 7 the whole bar. So next here minus 2 and minus 2 plus 7 are real numbers. Therefore, we are keeping the whole bar only on w. So next we are multiplying the terms in the left hand side and right hand side. We will get the terms are like 4 times of the whole thing, and right hand side also we are having the terms are like that. So next the left hand side I am moving the 4 inside. After simplifying, rearrange the terms, all the w terms in the left hand side and constant into right hand side. We will get the simplificative values are minus 22w minus 22w bar is equal to 49 minus 16. So now we know that w is equal to u plus iv, as well as w bar is equal to u minus iv. We must want to replace that into in place of w and w bar. We will get minus 22w minus 22 into iv minus 22 into u plus 22 into iv, because w bar is equal to u minus iv, minus into minus positive. So after simplifying, we will get minus 44u is equal to 33, because minus 22 iv plus 22 iv getting cancelled. So finally, I may cancel out 10, I will get minus 4u is equal to 3. So when you are moving minus 4u into right hand side, I will get my 4u plus 3 is equal to 3. This is what we want to prove in the given problem. So we may have some of the practice problem for your own practice. You have to